But so here we have something else that's pretty interesting. We always talk about antibiotic resistance and AI, and again, we come together here, uh, and the researchers here are holding this little uh, jumbled bit, and I would say that that's probably like a protein or something, because that's how we learned proteins look like. If you remember that, they're not just Lego pieces or whatever; they're just like little chaotic jumbles. So researchers look to AI to solve antibiotic resistance. Make sure you finish your antibiotics course, even if you start feeling better, is the medical mantra, but many hear but ignore. He explains that this phrase is, however, crucial as noncompliance could hamper the efficacy of a 20th century discovery, antibiotics. Which I think I've said this before, but if we don't have antibiotics, we're back in the Dark Ages, and all of society falls apart. Basically, it's gonna be like uh, living in medieval times again, but with guns. But in recent decades, this has led to the rise of drug-resistant bacteria, a growing global health crisis causing approximately 4.9 million deaths per year, and threatens to make even more common infections deadly. So, as well, it doesn't mention it, but a lot of this drug resistant bacteria. See, it's talking the way that the physics.org article starts it off here is you have to finish your antibiotics, but many people ignore it, and it's like people are the cause of it, right? Which I'm sure that there are a lot of people that do that and that people are a part of this problem. However, the majority of drug resistant bacteria and irresponsible use of antibiotics is in the industrial agriculture system. So I just had to say that it's like corporations are the ones that are mainly have the percentage of to blame here. And I feel like nobody wants to say that. They always try to shift it back onto the person, like an individual thing. Like it's the I mean, and in a way it is. I mean, people do need to take their medicine whenever they get it or whatever. That is a thing, and I do know people that don't. So like they have a point, but my point is that that's the people that are doing that is a very small fraction compared to the billions of animals being pumped with preventative antibiotics. You're not supposed to use antibiotics preventatively, but these corporations do, and they're not saying anything about it here. So what? It frustrates me that we have mainstream media that will not call out the corporations, probably because they're corporate media. So that's why we have to have like social, or I mean, not social media literacy, like media literacy, so that we can splice and dice these news articles and see their bias and see where they're coming from and like the truth behind it. Because unless it's somebody, like a citizen journalist that's out there on the street, it's hard to know and who to trust and what news places to trust, because they all have a spin or whatever. But there are still a few journalists out there that are good, and it's important to find those. And even if you have to cut through the BS, it is still good to keep up with science news and stuff like that. So it's kind of what we're doing, even if we're cutting through it. I just had to point all of that out. So with traditional methods, it takes around 6 years to develop new preclinical drug candidates to treat infections, and process is incredibly painstaking and expensive. Our deep learning approach can dramatically reduce that time, driving down costs as we have identified thousands of candidates in just a few hours, and many of them have preclinical potential, as tested on our animal models, signaling a new era of antibiotic discovery. These latest findings build on methods De La Fuente has been working on since his arrival in Pennsylvania in 2019. Can machines be used to accelerate antibiotic discovery by mining the world's biological information? He explained that this idea is based on the notion that biology, at its most basic level, is an information source, which could theoretically be explored with AI to find new useful molecules. The team started by applying sample algorithms that could mine individual proteins to find small antibiotic molecules hidden within their amino acid sequences. With advanced computational power, De La Fuente realized that they could scale up from mining individual proteins to mining entire proteomes. De La Fuente says a team began by looking at one protein at a time. Then, as computer efficiency and power improved, they were able to scale up. Next, he says they were able to mine whole proteomes, which are all the proteins encoded in an organism's genome, and this led us to discovering thousands of new antimicrobial molecules in the human proteome and later in the proteomes of ancient hominids like Neanderthal and Denisovians. Then we challenged ourselves to mine all extinct organisms known to science. The team developed what they call molecular de-extinction, which involves the revival of ancient molecules with potential therapeutic properties that have been extinct. And it brought back the discovery of therapeutic molecules in ancient organisms' genomes. They hypothesized that many of the molecules they are finding may play a role in host immunity throughout evolution. The idea culminated in a separate paper published in the Journal of Cell, for which he and his team conducted an extensive analysis of 87,920 genomes from specific microbes and 63,410 microbial genome mixes from environmental samples worldwide. This research identified 863,498 novel candidate antimicrobial peptides with more than 90% previously undescribed. Wow, that's a lot. And in recent Nature Biomedical Engineering paper, the team developed a powerful deep learning model called antibiotic peptide de-extinction, APEX, which can sample hundreds of proteomes across evolutionary history, helping identify the best antibiotic candidates from various organisms, including woolly mammoth, straight-tusked elephants, ancient sea cows, and extinct giant elk. Marcelo de Torosian Torres, co-first author of the study and postdoctoral researcher in the De La Fuente lab, says the team started building Apex by creating highly standardized data sets to train it with, which has been missing in the literature. It's surprising because there are so many data sets out there and researchers will use multiple sets, assuming all the samples were collected in a very systematic, consistent way. But that is not always the case. And Apex is probably the biggest, largest data set of the kind. AI will only be successful in a field as complex and chaotic as biology if we have high-quality data sets, De La Fuente says. We realized this many years ago and have been working hard to create data sets that can be used to train our organisms. The researchers note that Apex did a markedly better job of predicting activity than benchmark models, which it was able to mine through 10,311,899 peptides and identify 37,176 sequences with predicted broad spectrum antimicrobial activity, including 11,035 sequences not found in extant organisms. I don't know if that meant to be extinct or extant. Some of these showed effectiveness in preclinical mouse models of infection. It is a vital step as it moves these candidates closer to potential clinical trials and eventual therapeutic use. In addition, most of these archaic peptides have a new mechanism of action by depolarizing the cell membrane of a bacteria, a unique way of targeting them that hints at a new paradigm of infectious disease control. So that's really interesting. Depolarizing the cell membrane of a bacteria. Altogether, the computational work performed in De La Fuente lab in the past 5 years has dramatically accelerated the ability to discover new antibiotics. What used to take many years of painstaking work with traditional methods can now be done in just a few hours with AI. So I'm going to quickly go through this one, and I'll say that the rocket company develops massive catapult to launch satellites into space without using jet fuel, 10,000 times the force of Earth's gravity. So it's this giant circle with a tube, like a chimney, attached to the side of it, and this chimney is like a shaft, and they call it a barrel, and it says that it can fling 440-pound satellites into low orbit, and they already have successfully tested it. And there's no need for rocket fuel. It's all powered by electricity. And that it can launch satellites 600 miles up, and that they are traveling 5,000 miles per hour when they leave the chimney, and that it's 6 times the speed of sound, and that it's apparently a low cost, and the company credits the high strength modern carbon fiber and miniature electronics as key components behind the innovation. So that's pretty interesting. We will keep an eye on that sort of stuff. And they would be able to put up, like, build really big stuff up there. Hypothetically, if you were to go and like grab that stuff and then take it somewhere else, we could end up building something really big up there, should we want to. But then we have something, we're getting into the good ones here. This one's, honestly, I laughed whenever I saw this. Like, are we really at this point? It says it's from 3 days ago, and are animals conscious? How new research is changing minds. Charles Darwin enjoys a near godlike status among scientists for his theory of evolution, but his ideas that animals are conscious in the same way humans are have long been shunned, until now. There is no fundamental difference between man and animals in their ability to feel pleasure and pain, happiness and misery. But his suggestion that animals think and feel was seen as scientific heresy among many, if not most, animal behavior experts. Attributing consciousness to animals based on their response was seen as a cardinal sin. The argument went that projecting human traits, feelings, and behaviors onto animals had no scientific basis, and there was no way of testing what goes on in animals' minds. But if new evidence emerges of animals' ability to feel and process what's going on around them, could that mean that they are, in fact, conscious? We know now that bees can count, recognize human faces, and learn how to use tools. Professor Lars Chichta of Queen Mary University of London has worked on many of the major studies of bee intelligence. If bees are intelligent, maybe they can think and maybe feel something, which are the building blocks of consciousness. Professor Chichta's experiment showed that bees would modify the behavior following a traumatic incident and seemed to be able to play rolling small wooden balls, which, as he says, they appeared to enjoy as an activity. I didn't know that bees could play. That's interesting. These results have persuaded one of the most influential and respected scientists in animal research to make this strong, stark, and contentious statement. Given all the evidence that is on the table, it is quite likely that bees are conscious, he said. It isn't just bees. Many say that it is now time to think again. With the emergence of new evidence, they say, marks a sea change in thinking on the science of animal consciousness. They include Professor Jonathan Birch of London School of Economics. We have research from different fields starting to dare to ask questions about animal consciousness and explicitly think about how their research might be relevant to those questions. And they have a picture here. It says, octopus discovered to avoid pain and seek out pain relief in experiments. Cuttlefish. And they say octopus is one of the smartest animals on Earth, if not the smartest animal on Earth, like other than us, allegedly. Which is kind of funny. Cuttlefish. Remember details of specific past events, including how they experienced them. Crayfish. Display anxiety-like states when given mild electric shock, but were calmed on receiving anti-anxiety drugs. Crabs. Overcome their aversion to bright light if they have experienced an electric shock in a dark area, weighing up the intensity of the shock and the brightness of the light. Anyone looking for a eureka moment will be disappointed. Instead, a steady growth of evidence for a rethink has led to murmurings among the researchers involved. Now many want a change in scientific thinking in the field. What has been discovered may not amount to conclusive proof of animal consciousness, but taken together is enough to suggest that there is a realistic possibility that animals are capable of consciousness, according to Professor Birch. I'm like biting my tongue here, but I feel like this is so obvious. This applies not only to what are known as higher animals, such as apes and dolphins, who have reached a more advanced stage of development than other animals. It also applies to simpler creatures, such as snakes, octopuses, crabs, bees, and possibly even fruit flies, according to the group, who wanted funding for more research to determine whether animals are conscious, and if so, what extent. But if you're wondering what we even mean by consciousness, you're not alone. It's something scientists can't even agree on. An early effort came in the 17th century by the French philosopher René Descartes, who said, "I think, therefore I am." He added that language is not the only certain sign of thought hidden in a body. But those statements have muddied the waters for far too long. According to Professor Anil Seth of Sussex University, who has been wrestling with the definition of consciousness for much of his professional career. That's a wild statement. This guy, just this one guy, there's probably many of them, wrestling with the definition of consciousness for his entire career, or much of his career. That's like something you really have to take in there. And they call it an unholy trinity. I'm not really sure why they would go with that line of talking. I mean, maybe that's something he's talking about, a reference that I don't know about. But it says, this unholy trinity of language, intelligence, and consciousness goes all the way back to Descartes, he told BBC, with a degree of an annoyance at the lack of questioning of this approach until recently. The unholy trinity is at the core of movement called behaviorism, which emerged in the early 20th century. It says that thoughts and feelings cannot be measured by scientific methods, and so should be ignored when analyzing behavior. Many animal behavior experts were schooled in this view, but it is beginning to make way for a less human-centered approach. Because we see these things through a human lens, we tend to associate consciousness with language and intelligence. Just because they go together in us doesn't mean that they go together in general. And then they have another picture here. Cleaner wrasse fish recognize themselves in a mirror, indicating a degree of self-awareness. Zebrafish show sign of curiosity and show sustained interest in new objects. Bees show play behavior by rolling wooden balls for fun rather than for any useful purpose. Fruit flies have their sleep patterns disturbed by social isolation. Some are very critical of uses of the word consciousness. The field is replete with weasel words, and unfortunately one of those is consciousness. It is a word that is confidently used by a lot of people, but they all mean something different, and so it's not clear at all what it means. He says that a better, less Weasley word is sentience, which is a more tightly defined as the capacity to feel everything, a pinch, to see the color red, to feel tired, hungry. These are all things you feel. Others who have been instinctively skeptical of the ideas of animals being conscious say that the new, broader interpretation of what it means to be conscious makes a difference. Dr. Monique Udell from Oregon State University says she comes from a behaviorist background. If we look at distinct behaviors, for example, what species can recognize themselves in a mirror? How many can plan ahead or are able to remember things that happened in the past? We are able to test these questions with experimentation and observation and draw more accurate conclusions based on data. And if we are going to define consciousness as a sum of measurable behaviors, then animals that have succeeded in these particular tasks can said to have something as what we choose to call consciousness. That is a much narrower definition of consciousness than the new group is promoting, but a respectful clash of ideas is what science is all about, according to Dr. Udell. Having people who take ideas with a grain of salt and cast critical eye is important, because if we don't come at these questions in different ways, then it's going to be a lot harder of a progress. But what next? Some say far more animals need to be studied for the possibility of consciousness than is currently the case. Right now, most of the science is being done on humans and monkeys. We are making the job much harder than it needs to be because we are not learning about the consciousness in its most basic form. A professor of philosophy specializing in animal minds at York University, Toronto. Professor Andrews and many others believe that research on humans and monkeys is the study of higher level consciousness, exhibiting the ability to communicate and feel complex emotions, whereas an octopus or snake may have a more basic level of consciousness that we are ignoring by not investigating. Professor Andrews was among the prime movers of New York Declaration on Animal Consciousness, signed earlier this year, which has so far been signed by 286 researchers. The short paragraph declaration states that it is irresponsible to ignore the possibility of animal consciousness. We should consider welfare risks and use the evidence to inform our responses to these risks. Chris McGee is from Understanding Animal Research, a UK body backed by research organizations and companies that undertake animal experiments. He says animals are already assumed to be conscious when it comes to whether to conduct experiments on them, and says UK regulations require that experiments should be conducted only if the benefits to medical research outweigh the suffering. There is enough evidence for us to have precautionary approach. But there's also a lot we don't know, including about decapod crustaceans such as crabs, lobster, fish, crayfish, shrimp. We don't know very much about their lived experience or even basic things like at what point which they die. And this is important because we need to set the rules to protect them either in the lab or in the wild. A government review led by Professor Birch in 2021 assessed 300 scientific studies on the sentience of decapods and cephalopods, which include octopus, squid, and cuttlefish. Professor Birch's team found that there was strong evidence that these creatures were sentient and that they could experience feelings of pain, pleasure, thirst, hunger, warmth, joy, comfort, and excitement. The conclusions led to the government including these creatures into its Animal Welfare Sentience Act in 2022. Issues related to octopus and crab welfare have been neglected. The emerging science should encourage society to take these issues a bit more seriously. There are millions of different types of animals, and precious little research that has been carried out on how they experience the world. We know a bit about bees, and other researchers have shown indications of conscious behavior in cockroaches and even in fruit flies. But there are many other experiments to be done involving so many other animals. It is a field of study that modern-day heretics who have signed the New York Declaration claim has been neglected, even ridiculed. Their approach to say the unsayable and risk sanction is nothing new. Around the same time that René Descartes was saying, "I think, therefore I am," the Catholic Church found the Italian astronomer Galileo Galilei vehemently suspect of heresy for suggesting that the Earth was not the center of the universe. It was a shift in thinking that opened our eyes to a truer, richer picture of the universe and our place in it. Shifting ourselves from the center of the universe a second time may well do the same for our understanding of ourselves, as well as other living things whom we share the planet. So that's kind of like a revolution of our consciousness and of ourselves even, and our perceptions. But I want to know if you guys have ever thought that animals had consciousness or did not have consciousness. Has that ever been a thought for you, that animals were not conscious? I would love to hear from you guys. I might set up a poll on YouTube or Spotify or something, because I was really interested in that. But yeah, I just have never even questioned that animals are conscious. Of course they're conscious, but I guess some people have to have that proven to them, which is weird. But yeah, we'll just move on.